Welcome to Quick Course Digest. Today we're going to talk about something that sounds super technical, but it's really about one simple idea. How do top-tier companies get things so close to perfect? We're diving into Six Sigma.
So let's just jump right in with a scenario. Picture this. You're the boss at a high-end luxury car company, and things are not great. Your production line is slowing down, and even worse, customers are complaining about faulty windshield wipers. The pressure is on. What's your first move?
Well, believe it or not, there's a proven playbook for tackling exactly these kinds of complicated, messy problems. It's called Six Sigma, and it's basically a roadmap for finding out what went wrong, why it went wrong, and how to make sure it never happens again.
So what is this thing really? At its heart, Six Sigma is all about using data. We're talking hard facts and numbers. Use that data to go on a kind of treasure hunt, looking for the root cause of any error or delay in a process. The whole point is to make that process as smooth and error-free as humanly possible.
And when I say error-free, I mean it. The standard Six Sigma sets is just staggering. Achieving Six Sigma quality means your process is 99.9996% perfect. Let's put that into perspective. That translates to only 3.4 mistakes for every million chances. That's like sending a typo in a text message only once every couple of decades. It's about as close to absolute perfection as you can get in the real world.
And you know, this isn't some brand new business trend. Six Sigma actually got its start way back in the 1980s with an engineer named Bill Smith at Motorola. But by the 90s, companies like GE made it famous. And today, it's a fundamental tool for any organization that's serious about being the best.
Okay, so Six Sigma has two main flavors, or methodologies. Let's talk about the first one, DMAIC. This is your go-to toolkit when you've got a process that's already up and running, but it's broken, just like our struggling car factory.
DMAIC is a simple acronym for 5 steps: define, measure, analyze, improve, and control. It's a really logical way to tackle a problem. So let's use it to fix our car factory, step by step.
First up, D for define. You can't fix a problem you can't describe. So for the car company, we'd clearly define the issues. 1, the windshield wipers are failing quality checks. And 2, we need to double production from 1,000 cars a day to 2,000.
Next, M for measure. This is where you put on your data scientist hat. You need to get a baseline. How is the process performing right now, before you change anything? So you confirm, yep, we're making exactly 1,000 cars a day. And you'd measure the defect rate from every single one of those 30 wiper installation machines.
Now for the fun part. A for analyze. You take all that data you just collected and you dig in to find the real underlying causes. And bingo! The analysis shows 2 things. First, one specific wiper machine is responsible for almost all the defects. And second, the entire assembly line is slow because wheels are put on at the very end, meaning cranes have to move the heavy car bodies around.
Once you know the why, you can get to the how. I for improve. The solutions are now obvious and targeted. You replace that one faulty wiper machine, and you change the assembly order to put the wheels on much earlier. Now the chassis can just be rolled along the line. No more cranes. Simple, but brilliant.
And finally, C for control. This step is absolutely critical. You can't just fix it and walk away. You have to put checks in place to make sure the process stays fixed. You monitor the new system to ensure the improvements stick. And for our factory, the result is huge. They're now making 2,000 high-quality cars a day. Problem solved. Okay, but what if you're not fixing something old? What if you're building something totally new? That's where the second Six Sigma methodology comes into play. It's called DMADV. Imagine our car company now wants to design a revolutionary new sports car from a blank sheet of paper.
DMADVD stands for Define, Measure, Analyze, Design, and Verify. People often call it Design for Six Sigma, or DFSS, because it's all about baking quality into a product right from the start, not trying to fix it later.
So first you define what the customer actually wants, and then you measure those desires to turn them into concrete engineering specs. For our new sports car, market research might say customers crave a top speed over 150 miles per hour, they want a beefy V6 engine, and it has to have a sleek aerodynamic frame.
Then you analyze different design options and, well, you design the thing. Let's say the engineers built a prototype that hits the engine and aero goals, but it's just not fast enough. The analysis would lead them to explore new materials, and they'd end up designing the final car with a cutting-edge, lightweight aluminum alloy to nail that top speed.
The last step here is V for verify.
You have to prove that your new design actually works in the real world and meets what the customer asked for. So after launching the sports car with its fancy new frame, the company would pore over customer feedback and test data, which confirms, yes, the car is a massive success, praised for its speed and agility.
So let's just quickly recap the two. DMAIC is all about fixing something that already exists, it's problem-focused, and its last step is to control the fix. DMADV is for creating something brand new. It's solution-focused, and its last step is to verify the design. Simple as that.
Now, it's really important to understand that Six Sigma isn't just for making cars. Its core ideas are so flexible that they've totally transformed industries all over the world.
I mean, it's used everywhere. In hospitals to reduce patient wait times and improve safety. In banking to make loan approvals faster. In software to squash bugs before they get to you. Even in government agencies in the petrochemical industry. The applications are pretty much endless.
And I have to mention Six Sigma's close cousin, a methodology called Lean. While Six Sigma is obsessed with reducing defects, Lean is obsessed with eliminating waste, anything in a process that doesn't add value for the customer. They complement each other so well that most companies now combine them into one powerful system called Lean Six Sigma.
So there you have it. Six Sigma is a powerful, data-driven way to chase perfection, which kind of leaves us with one final thought. With a tool that can systematically wipe out waste and perfect almost any process, what in your world, at work, or even at home could be just a little bit better with a dash of Six Sigma thinking?